The fuselage of a rubber-powered model must not add undue weight to the total structure, but at the same time be strong enough to withstand the tension and torsion forces applied by a fully wound rubber motor. It must also be straight. A twisted or banana-shaped fuselage will throw the flying surfaces out of alignment, making the model nearly impossible to trim for flight. Achieving this compromise of strength and lightness is no easy feat. It demands carefully selecting each piece of balsa wood for the purpose it serves. For instance, uprights, except those holding the rubber motor anchor peg, need not be as strong as the longerons, which must withstand the strain of the rubber motor. The longerons need to be almost identical in hardness and stiffness in order to build a straight fuselage. If the longerons on one side are more stiff than the other, the result will be a banana-shaped fuselage. The first step in producing matching longerons is stripping the square strips from a single sheet of balsa. The thickness of the sheet will depend on the model being built. John Johnston, who is without a doubt a master modeler, uses 1/20th inch sheet almost exclusively for his peanut scale models. Of course, larger models require larger components. The inexpensive Master Air Screw balsa stripper is an excellent tool for producing balsa sticks of any size. Just make certain that you have a sharp blade and work carefully. Even strips taken from the same sheet of balsa can vary in stiffness. In his constant search for perfection, John has constructed a simple but effective device for measuring the stiffness of balsa strips. Plans for building this device were published in the newsletter Indoor News and Views, but you should be able to make one from what we show in this video. Each strip is placed in the device and a weight formed from copper wire is hung on the free end. The deflection is noted and strips with similar deflection are placed in the same pile. Fuselage construction begins by using scraps of balsa and pins to build what is, in effect, a jig. The top longeron is held in place by this jig and assumes the shape of the top of the fuselage. John's method of placing the uprights is a bit different than the traditional method, but it assures a strong, straight structure, and it's also easy to perform. Rather than cut the uprights to length, leave them long. This allows you to place a pin directly through the upright outside the fuselage outline, where it will cause no structural damage. This same procedure is used for all of the uprights. Once the uprights are in place, very carefully cut them to the exact length as shown on the plan. The bottom longeron is now glued into place and the structure is allowed to sit until completely dry. Once you're certain the glue is dry, remove the structure from the plan. Be careful not to disturb the jig you used for the top longeron. Using this same jig will allow you to build the second side as a replica of the first. With both sides completed, it's time to drill the hole for the tube that anchors the rubber motor. Hold both sides together as you drill this hole to make sure that the anchor peg will be held straight. A drill press will provide you the most accurate holes, but a hand drill can be used if you're careful about alignment. The next step is to turn the two sides into a finished fuselage by using the cross pieces to glue them together. If you study most fuselages, you'll find there's one section that forms a box with square corners. This is where to begin. John uses tight bond glue almost exclusively, and one of its properties is how well it holds components if you pre-glue. Pre-gluing is merely placing a small dab of glue where the components will meet and then wiping it off. Once the tight bond is dry, or at least tacky, the next coat of glue is used to hold the component in place. Proceed by pinning the cross pieces to the fuselage top view at each end of this box. The fuselage sides are then glued to these cross pieces. Note that most fuselages have at least one section on the top that is flat. This allows you to pin the structure to the plan and use braces, weights, or triangles cut from balsa to keep everything in alignment. Again, make certain the glue has dried so that the cross pieces are firmly attached to the fuselage sides before the next step. With the top cross pieces in place, the corresponding bottom cross pieces are pre-glued and then glued in place. Keep everything square and in alignment until the glue is thoroughly dry. While waiting for the glue to dry between all of these steps can try your patience, it's absolutely necessary for a strong and aligned fuselage. If you're the fidgety type, work on other components of your model as the glue sets up. It's what we did while producing this video. The rear of the fuselage is carefully pulled together and glued. Now, the rest of the cross pieces and/or formers can be glued in place. Those of us who remember the early days of model aviation began by cutting out our formers with a single-edge razor blade. It was a tedious task, and we usually ruined the piece while we attempted to notch the former using the same blade. John simply roughs out his formers with a modeling knife and then sands them to shape with a sanding disc. As you can see, John builds many of his power tools. You can do the same, or use a Dremel disc and belt sander. If power tools are not in the budget, you can accomplish the same task with the sanding block. John uses small machinist files to cut notches in formers. This method is far superior to cutting notches with razor blades or modeling knives, as there's much less chance of splitting the wood. In fact, John uses several shapes of machinist files for various model building tasks. Always a stickler for lightweight construction, John uses a drum sander on his Dremel Mini-Mite cordless tool to sand away unneeded wood. The Mini-Mite is preferred over the corded tools as the torque developed is less. This allows more control during sanding operations. With the formers in place, the stringers are added using the notches you've filed, and the fuselage is basically completed. Eliminating as much unnecessary wood from the wing as possible will help you keep your model's overall weight to a minimum. The trick is to keep the weight down without weakening the structure. Sliced ribs are the answer to this problem. Begin with a pattern for the airfoil you want to use. Choose a light piece of balsa of the proper thickness and cut a section off the bottom using your airfoil pattern. Glue this section of balsa onto the bottom of your airfoil pattern so that when it's pressed up against the bottom of the balsa, the next cut will be at the proper depth of the rib. You can now slice a series of uniformly sized ribs with very little effort. Wing construction is much like the first stages of fuselage construction. The leading edge is held in place by pins, but remember, you never pin through any component that will become part of the model. You can pin down the bottom strip for the ribs just like you did for the fuselage uprights, as long as the pins are outside the wing outline. When they are securely glued in place, the bottom strips are carefully trimmed to length. The dimensions of these strips are dictated by the wood being used to build the model. John uses 1/20th inch square for his peanut models, but others use 1/16th inch square. Larger models will need larger strips. The trailing edge is glued to the bottom rib strips. The sliced ribs are now marked and cut to length. Always cut from the trailing edge of the rib and never from the leading edge. Notice how the bottom of each rib is cut flat, using the line on the cutting board as a guide. These cutting boards are available at most office or art supply stores and are indispensable for cutting out parts. Each rib is glued to the bottom strip, leading edge, and trailing edge. Lightweight, strong, and warp-resistant wingtips and other curved components are made by laminating strips of obici or balsa around a form. Excellent forms can be made from the bottom of foam meat trays. The form is cut to shape and the edge coated with wax or crayon. Pin the forms down to a building board that has been covered with waxed paper to prevent the glue from sticking to the board. The most commonly used strips are 1/32 thick by the height of the tip. Obici wood is easily bent and can be worked dry. Balsa, however, needs to be thoroughly soaked in water to make it more pliable. Coat both sides of the center strip with aliphatic glue. Press the two outside strips to it. Hold the lamination in place with scrap balsa and a pin. Use a pulling motion to bend the lamination around the form and, again, use a piece of scrap balsa and a pin to hold it in place until the glue dries. Don't try to hold it in place with just pins, as they will dent the wood. One of the advantages of the sliced rib method is that the dihedral is built right into the spars. The spars are tapered to fit inside the sliced ribs. This might take a bit of measuring, but it's easily done. Pin the right and left spars down to the plans and glue them together. Braces, cut to the correct dihedral angle and glued to the spars where they meet, will provide strength. One wing is now slipped over the spar and glued in place. Use the plans for positioning. You might need to touch up the spar with sandpaper in spots in order to get a proper fit. With the wing placed on the plan, make sure the spar is in correct alignment, and then glue the spar to the top ribs and to the wingtip. Turn the wing over and glue the bottom ribs to the spar. The spar is then inserted into the second wing. Glue the two wing halves together at the center. Hold the structure together by pinning it to the plant. A block placed under the inclined wing will hold it in place while the glue dries. Glue the ribs in the second wing half to the spar just as you did the first wing. When the glue is dry, you'll have a straight, lightweight wing with a dihedral set at the correct angle. Strong, lightweight scale wheels can be made by laminating balsa to the required thickness. Begin by cutting balsa squares to the dimension you'll need. The thickness of the balsa depends on the thickness you need for the scale size wheels. Using a straight edge, mark the center of the laminated square of balsa. Draw the wheel outline using a compass with a soft lead. The corners of the squares are cut off using a razor saw such as an X-Acto or Zona saw. The wheel is then shaped to a perfect circle by using a pin as the axle and turning the lamination against a sanding disc. Note that the pin is pushed through the lamination and into a board that has been clamped to the table of the sanding disc. John uses a piece of music wire and wheel collars to place the wheel into a Dremel tool for finishing. With the Dremel set to a slow speed, the wheel can be shaped with a sanding block. After the outside shape of the wheel is completed, a machinist file is used to create the shape of the hub. Additional shaping is done using an ordinary emery board. The rear of the wheel is shaped using the same procedure. For more realism, use the file to cut a tread into the wheel. All that's needed now is paint, and you have a very realistic wheel that will add very little weight to your model. To make a scale spinner, begin by finding the center of the balsa block and punch in a starter hole. Trim the corners with a razor blade or modeling knife. Since you do not want to drill a hole all the way through your spinner block, use the Dremel screw-type tool that is used to attach buffing wheels. Simply screw this tool into the pilot hole in the spinner block. The spinner is now shaped using a sanding block. Sanding balsa creates a lot of potentially dangerous dust, and you should always wear a dust mask while performing any sanding operation. The finished spinner is light, but it can be made lighter. John hollows out his spinners using a Dremel tool and a tapered grinding wheel. He must be extremely careful while performing this task to prevent injury, but it certainly makes a lightweight spinner. Duplicating the spoked wheels used on many early aircraft might cause some modelers to shy away from them as scale subjects. Actually, however, it's not as difficult to construct lightweight spoke wheels as you might think. The first step is to create the wheel rim. With a balsa disc chucked in the Dremel tool, mark the depth of the rim with a compass. Shape the rim with an emery board and then smooth it with 320 grit sandpaper. A machinist file and emery board are used to finish shaping the rim. The file is then used to cut it free from the disc. You'll need 4 of these rims to make 1 pair of wheels. The pattern to lay out the spokes can be drawn on a sheet of paper. The easiest way we've found is to draw a circle the same size as the rim, and then, using the same center point, draw a larger circle. The larger circle makes it easier to divide the circle into even increments. For a wheel containing 20 spokes, divide the circle into increments of 18 degrees. Pins are placed on these radials at the larger circle. The hub is cut from aluminum tubing, or you can wrap your own from lightweight tissue paper. Any burrs formed in the cutting process can be cleaned up with files. To make this job easier, try holding the tubing in a pin vise. Thread is used to simulate the spokes, and a fly tying bobbin is a handy tool when working with thread. The thread used to wrap fishing rod guides comes in several colors and makes excellent spokes. 1/2 of a rim is placed on the pattern and a vertical wire is inserted in the center hole. This wire should be the same size as the ID of the tubing used for the hub. The rim is elevated by a couple of pieces of scrap 1/16 inch balsa. The thread is attached to the vertical wire with a couple of half hitches. Wrap the thread around the pins, skipping a pin each time. Always wrap in the same direction. John prefers clockwise. When you reach the final pin, tie off the thread with a couple of half hitches. The aluminum tube is now slipped over the wire and pushed down on the threads. Take a few moments to line up the spokes and then dab a very light touch of CA glue to hold the thread to the rim. With the CA dry, continue wrapping. This time using the pins you skipped the first time around. When you complete wrapping the second set of spokes, use a touch of CA to hold them. The second rim is now glued in place. A few weights will keep it from moving until the glue dries. By coloring the rims with a black Sharpie pen, you'll have a very credible looking pair of spoked wheels. To make lightweight laminated propellers, strip 1/16 inch balsa to a width of 3/8 inch to 1/2 inch. You can experiment with other widths, but this range will work fine. Cut the strips to the proper length for the propeller you are making. Coloring the strips with a magic marker will enhance the laminated appearance of the finished prop. You also might use alternating colors for an even more attractive accent. After drilling a 1/16 inch hole for the prop shaft in the exact center of each strip, place them over a length of music wire that has been inserted and glued into a piece of board. Use a 30-degree balsa triangle to line up the strips to the proper pitch. Then mark the strips with a fine tip ballpoint pen. Mark the top strip along both sides of the wire axle to use as a guide when you carve and sand the prop. Remove the strips from the jig, being careful to keep them in the proper sequence. Use Titebond or other aliphatic glue to join the slabs in the same sequence that they came off the jig the first time. Use the lines you have drawn for alignment. Do not use any sort of adhesive that is difficult to sand. For instance, the new Titebond 2 is extremely difficult to sand, and you will develop ridges in the finished prop where the balsa has been sanded away and the glue remains. Weight the stack of slabs and allow the glue to dry. When the glue is dry, begin shaping your prop with a modeling or carving knife. Note that John uses a Rapella fish filleting knife. Its curved blade makes it an ideal addition to your model building toolbox. Follow up the carving with sandpaper, then continue to alternately carve and sand the prop to shape. For final shaping, John uses his trusty Mini-Mite rotary tool. The result of the laminated technique of propeller construction is a very efficient and attractive propeller. Building and flying rubber-powered scale models can be a challenge, but it also can be very rewarding. By using the techniques presented in this video, even a beginning modeler can produce better than average rubber-powered scale models. Just remember to build them light and build them straight, and most of all, have fun.